Ever feel like you're just swimming in information? You know, articles, research, even your own notes piling up, and you're thinking, how do I find the really important stuff quickly without getting lost? Imagine having like an expert guide right there, sorting through it all, just pulling out the key insights for you. Well, that's pretty much what we're doing today on the deep dive. We're jumping into the really fascinating world of multimodal AI. We're going to explore how AI is getting, frankly, a lot smarter by learning to understand information from different senses, like, sight, sound, text, kind of like how we humans do it.
Exactly. And to help us navigate this, we've gathered some really interesting sources. We've got a hands-on guide about building an AI tool using Google's Gemini Pro, something pretty practical. Then there's a broader overview explaining how this multimodal AI actually works and where it's making an impact already. And finally, a research paper that gets into the nitty-gritty of how AI finds specific visual information, like looking for data in charts. So this set of sources should give you a really solid grounding.
Okay, so AI understanding multiple senses. Let's unpack that a bit. What actually is multimodal AI? How is it different from the AI we might be more familiar with?
Right, good place to start. So fundamentally, multimodal AI is about an AI system that can process and crucially integrate data from several different sources, or modalities as they're called, all at the same time.
Modalities. So that's the different senses for the AI.
Precisely. We're talking about things like text, obviously written or spoken words, but also images, audio, video, even data from sensors like you'd find on a self-driving car or a robot. You could maybe think of it as a really advanced translator. But instead of just translating languages, it's translating and connecting insights from pictures, sounds, text, making sense of it all together.
Okay, connecting it all together. How does that differ from, say, a standard AI?
Well, traditional AI, sometimes called unimodal AI, usually just handles one type of data at a time. Like a language model works with text, an image recognition system works with images separately. Multimodal AI looks at them simultaneously, and that simultaneous processing lets it build a much richer, more context-aware understanding. It sees the bigger picture.
That sounds like a pretty significant step up. Why is that synergy so important? What does it unlock?
It matters hugely because it makes the AI much more robust, much more useful. When you combine information from different senses, the AI can figure out things that might be ambiguous if it only had one source. Think about it from your perspective. It allows for much more natural interaction. The AI starts to feel less like a rigid tool you have to command just right, and more like, well, an expert helper that kind of gets what you're after.
That idea of getting what you're after, that more human-like understanding, is really interesting. It's a bit concrete. Our first source talks about using Google's Gemini Pro to summarize PowerPoints. I mean, that sounds super useful. A tool that doesn't just read the text, but understands the charts and graphics too. How does that actually work?
Yeah, it's a great example. And to understand it, it helps to know a little bit about Google's Gemini models. There's actually a whole family. You've got Gemini Nano, that's the small one, designed for on-device tasks, like on Pixel phones. Then there's Gemini Pro, which is the mid-range one, the one available publicly, and that's the key for this summarizer tool. And importantly, it has two versions, one just for text, and one, the vision model, that handles both images and text.
Ah, okay, so the vision model is the one looking at the slides.
Exactly. And then there's Gemini Ultra, which is the biggest, most powerful one for really complex stuff involving video and audio. But the point is, this generation of AI is flexible.
Right, so for the PowerPoint summarizer, using Gemini Pro Vision, how does it go from slides to a summary?
It's quite neat, actually, at a high level. You upload your PowerPoint file. The tool then basically takes a snapshot, converts each slide into an image. Then the Gemini Pro Vision model analyzes each of those images, each slide, and generates a short summary for it. And finally, it just shows you the complete summary slide by slide. Pretty straightforward process for the user.
Okay, simple process. But getting the right kind of summary, I know with these AI models, how you ask the question, the prompt, is really important. How do they handle that?
You're absolutely right. Prompt engineering is critical. The article gives a good example of the kind of prompt they use. It wasn't just summarize the slide. It was much more specific. Something like, you are a PowerPoint PPT assistant. Generate a cohesive summary, max 5 lines for the slide image. Give it a title. Make sure the info relates to the slide content. And crucially, it added, also, if there are any charts, graph include relevant numbers explaining the charts. So it explicitly tells the AI to act like an assistant and to pull out data from visuals.
Okay, telling to grab the numbers. Did that actually work in practice? Could it really see the data in the charts?
Apparently, yes. The demo they mentioned used a presentation about an Indian government initiative called Swachh Bharat. It's about sanitation and cleanliness, and Gemini Pro successfully pulled out specific numbers and insights from the graphs on the slides. Things like comparing funds spent on different projects or specific statistics about urban sanitation. So yeah, it really showed the AI wasn't just reading text around the chart, it was actually interpreting the visual data itself, reading the bars, the labels.
That's impressive.
Yeah.
So taking that example and broadening out, how do these systems generally work? How do they manage to blend all these different inputs, text, images, sound, into one coherent understanding?
Well, it goes back to those modalities or building blocks. Each type of data, text, image, audio, whatever, offers a unique piece of the puzzle, right? Often just one type of information doesn't give you the full story. A picture might show what happened, but the audio could tell you how people felt about it. Text gives you the facts, maybe.
So they need a way to fuse it all together. What does that look like inside the AI? Is there a central hub?
Conceptually, yes. You can think of most multimodal AI models having sort of three main stages. First, an input module. This is like the AI's different senses. It has specialized bits for handling images, different ones for text, for audio, and so on. They process the raw data coming in. Then all that processed information flows into the fusion module. This is really the core of it. It's where the information from the different streams is combined, aligned, and integrated to create a single, unified understanding. That's the tricky part. And finally, there's an output module. This takes that unified understanding and generates the result you want. Maybe it writes a text summary, maybe it generates an image, maybe it answers a spoken question.
And this fusion, does it help clear up confusion? Things where one sense alone might be misleading.
Definitely. That enhancement of contextual understanding is a huge win. Think about the word bat. Does it mean the animal or the piece of sports equipment? If you just see the text bat, an AI might be unsure. But if it also sees an image of a baseball game, problem solved. The visual context clears up the ambiguity, just like it would for us. It leads to results that feel much more grounded, more, well, human-like, because the AI has more context to work with. Avoids those silly misunderstandings.
Right, avoids those moments where you ask for one thing and get something completely different.
Yeah.
And where did the big large language models, the LLMs like GPT or Gemini, fit into this picture? Are they like the brain coordinating the senses?
That's a really good way to put it. Often, yes. LLMs frequently act as the sort of linguistic backbone or the reasoning engine within the multimodal system. They're incredibly powerful at understanding and generating human language. So, in a multimodal setup, the LLM helps connect the dots between the language part and the information coming from images or audio. It helps interpret the combined data, formulate coherent responses, and even perform complex reasoning that needs both language and visual or auditory understanding. It gives the whole system its ability to communicate effectively.
Okay, so this isn't just lab stuff. You mentioned real-world impact. Where are we actually seeing multimodal AI being used right now? How is it changing things?
Oh, it's already making waves across loads of industries. In healthcare, for instance, it's being used to analyze medical images, the X-rays, CT scans alongside the patient's electronic health record, the doctor's notes. This helps provide more accurate diagnoses, suggest potential treatment plans. There are models like EllaMed specifically trained for this. It's like giving doctors an incredibly observant assistant.
Wow, okay. That's huge for medicine.
Yeah.
What about something like, say, getting around?
Absolutely. In transportation and robotics, self-driving cars are a prime example. They're constantly fusing data from cameras, LiDAR, radar, GPS, sensors, all to navigate safely. And robots in factories or warehouses are using it to understand spoken commands while also visually identifying objects or navigating their environment.
And for everyday interactions, like shopping or customer service.
Big impact there, too. In retail, you might have virtual assistants that can look at a photo of an outfit you like and then find similar items, or analyze a picture of your glasses to recommend the right size for new frames. For customer support, chatbots are moving beyond just text. They might analyze the tone of your voice, maybe even facial expressions in a video call, along with your words, to better understand your sentiment. Are you frustrated, happy, and respond more appropriately.
It could make customer service a lot less frustrating. What about creating content? Or marketing?
Yeah, content creation is another area. AI is starting to generate not just text, but videos, interactive experiences, personalized ads. By understanding what makes content engaging, looking at expressions, analyzing voiceovers, matching visuals to text, and think about education. AI tutors that can see a student's work, listen to their explanation, and look at their facial expression to gauge understanding, then adapt the lesson accordingly.
That sounds incredibly personalized. Security, too, I imagine.
For sure. Security and surveillance systems use it to analyze video feeds, audio detectors, sensor data all together to spot suspicious activities more reliably than just watching screens. Banks use it for advanced fraud detection, looking at transaction patterns alongside other signals.
And who are the main players developing these kinds of models? You mentioned Google's Gemini.
Right, Google is definitely a big one with Gemini, designed natively multimodal. OpenAI's GPT-4 with Vision was a major step. Meta has models like ImageBind that work across, I think, 6 different modalities. Microsoft is integrating these capabilities heavily into Azure AI and their Copilot assistants. And importantly, there's a lot happening in the open source world, too, with models like Elevate or Mistral's Pixtral pushing the boundaries. It's a very active space.
Okay, so lots of potential, lots of activity. But like any powerful new tech, there must be challenges, right? Hurdles to overcome. That research paper you mentioned, the one about retrieving charts, that seems to hint at some of the practical difficulties. Finding one specific chart using text sounds simple, but I guess it's not.
It's definitely not simple. That paper really highlights the nuances. The basic problem was, you describe a chart you're looking for, say, show me the graph of population growth in Europe, and you want the AI to find the image of that specific chart from a huge collection. They tested a few different ways to tackle this. One was basically using OCR optical character recognition to just pull all the text off the chart image and then search the text.
Like reading the labels and title.
Exactly. Another approach was more complex, trying to de-render the chart, essentially converting the visual information back into a data table, like a spreadsheet, and then searching the table. Then there was using a vision language model, or VLM, to have the AI directly look at and understand the image itself. And finally, combining some of these methods.
Trying different angles to see what works best for reading charts. What did they find? Were there any surprises?
There were definitely some interesting, maybe even surprising findings. They found that, yeah, combining methods like using both the de-rendered table data and direct image understanding often gave the best results overall. Makes sense, using more info. But the de-rendering method, while efficient, actually struggled with really complex charts like messy scientific plots with lots of subgraphs or charts that had tons of text like explanatory notes or long titles. Think of some complex Pew Research charts, for example.
Okay, so the fancy method wasn't always best.
Right. The direct image understanding models were better at those visually complex ones, but they need a lot more computing power. They're computationally expensive. But here's the kicker. That basic OCR method, just grabbing the text, actually performed really well, specifically on those text-heavy charts. If the words in your search query were actually printed right there on the chart image, OCR was great at finding it because, well, it reads text. It showed that sometimes the simplest tool is the right one for a specific job, even if it's less sophisticated overall. Context matters a lot.
That's a great point. It's not always about having the most complex tool, but the right tool. So beyond specific tasks like chart retrieval, what are the bigger roadblocks multimodal AI faces?
Well, there are a few significant ones. First, the sheer computational and beta demands. Training these massive models that handle diverse data types requires enormous data sets and huge amounts of computing power. That's expensive and can be an environmental concern, too.
Resource intensive. What else?
Ethical considerations and bias are huge. AI models learn from the data they're trained on. If that data reflects societal biases, and it often does, the AI can inherit and even amplify those biases. This is a major concern, especially in sensitive areas like healthcare or hiring.
Right, the bias problem. That's critical.
Then there's privacy and security. When you're dealing with images, voice recordings, potentially sensitive sensor data altogether, the risks of privacy breaches or misuse of data increase. You need really robust safeguards.
Makes sense. More data types mean more potential vulnerabilities.
Exactly. And finally, there's the ongoing challenge of interpretability, sometimes called the black box problem. It's often really hard to understand exactly why a complex multimodal AI made a specific decision or prediction. That lack of transparency makes it difficult to trust the system, debug it when it goes wrong, and ensure it's behaving fairly.
Okay, so significant challenges. But you mentioned they're being worked on. Looking ahead then, despite these hurdles, what's the future look like? Where is multimodal AI taking us?
The future trajectory looks incredibly exciting, honestly. One of the biggest impacts will be in fundamentally reshaping how we interact with machines. Expect interactions to become much more natural, much more intuitive. We'll be blending voice commands, maybe touch screens, gestures, perhaps even the AI reading facial expressions, all seamlessly. Your AI assistant will feel less like a machine you command and more like something that adapts to you.
So moving beyond just typing or talking to a more holistic interaction.
Precisely. And we'll also see the continued rise of multimodal generative AI. We talked about generation. This will get even more sophisticated. AI won't just write text or make an image. It'll create rich, complex content that weaves together video, audio, text, and interactivity. Think AI creating entire movie scenes or complex educational simulations. It's like turbocharged creativity.
Wow, AI as a creative partner, almost. What about those AI assistants becoming more helpful in anticipating our needs?
That's definitely on the horizon, AI moving towards understanding human intentions, not just commands. Imagine, instead of searching for a manual, you just point your phone at, say, a broken washing machine. You explain the problem out loud. It's making this weird noise and not draining. And the AI understands the context, maybe recognizes the model from the image, analyzes the sound you mentioned, and guides you through a solution, perhaps showing a relevant diagram. It anticipates what you need.
That would be incredibly useful, taking away so much friction. And how does this all feed into that ultimate goal? So some people talk about artificial general intelligence or AGI.
It's seen as a really crucial stone. The ability to process, integrate, and reason across multiple modalities like humans do with our senses is fundamental to how we understand and interact with the world. So, developing robust multimodal AI is considered a key part of the path towards achieving AI with more human-like cognitive abilities, potentially leading towards AGI someday. It's teaching AI to perceive the world more like we do.
So really, what we've explored today is more than just a new tech feature, isn't it? It feels like a fundamental shift. We're getting closer to AI that understands the world and us in a much more complete way.
Absolutely. It's a foundational change. And for businesses, for individuals, the opportunities are immense. Deeper insights from data, better decision making, richer customer experiences, new creative possibilities. It really is set to change how we work, how we communicate, how we live alongside technology. So maybe something to think about as you go through your day. Notice all the different ways you take in information, what you see, what you hear, what you read, maybe even touch or feel. And then try to imagine an AI that can do all of that too and connect it all together. What possibilities does that open up? And maybe what questions does that raise for you about the kind of future we're building with AI?